Hi everyone, this is the third lesson in statistics, measures of dispersion. With our targets, we're going to find the range of a data set, that's a measure of dispersion. We're also going to calculate what's called the standard deviation. We're going to interpret measures of dispersion and calculate a coefficient that shows the variation. Sometimes we want to look at a measure of dispersion or spread of the data. Two of the most common measures of dispersion are the range and the standard deviation. For any data set, the range of the set is given by the greatest value minus the least value in the set. Two sets below have the same mean and median of 7. Find the range in each set. So the range in set A is going to be the largest value minus the smallest value. 13 minus 1 is 12, whereas the range in data set B is the largest value minus the smallest value, which is 4. So even though they have the same mean and median, you can see that these are very different sets because their dispersion or their spread is very different. One of the most useful measures of dispersion is the standard deviation, and it's based on the deviations from the mean of the data, or how much are each of the numbers different in comparison with the average number. Find the deviations from the mean for all data values of the sample 1, 2, 8, 11, and 13. The mean is 7, so we could calculate that. If we add up all these numbers, 3, 11, 22, and 35, and divided by 5 numbers, the mean is 7. Subtract to find the deviation. So subtracting, if the mean is 7 and the data value is 1, then the deviation is 6. That's 7 minus 1. 7 minus 2 is 5. 7 minus 8 is negative 1. 7 minus 11 is negative 4. And 7 minus 13 is negative 6. So there's our deviations. The next word is the variance. The variance is found by summing the squares of the deviations and dividing that sum by n minus 1, since it's a sample instead of a population. The square root of the variance gives a kind of average of the deviations from the mean, which is called a sample standard deviation. It's denoted by the letter S. The standard deviation of a population is denoted by a sigma, a lowercase sigma, which looks like that. We saw the uppercase sigma to be the sum. Let a sample of n numbers, x1, x2 through xn, have a mean x bar. Then the sample standard deviation S of the numbers is given by, all right, so we're going to subtract the number from the mean, but then we're going to square it, and we're going to sum up those values and divide by n minus 1 since it's of a sample. Okay, so that's the variance, and then the standard deviation is to square root that. Here's how to do it listed out as steps. Calculate the mean is step number 1. Then find the deviations from the mean, so subtract. Then we're going to square all of those. we're going to add up all of those numbers, divide by the how many numbers there are minus 1, and then take the square root of that answer. Here, let's find the standard deviations of the sample here, 1, 2, 8, 11, and 13. Okay, so this was the 5 numbers. We added them up before and got 35 divided by 5 numbers is 7. So the mean is 7. Then we subtracted these to get deviation. But now we're squaring these. So 6 squared is 36. 5 times 5 is 25. Negative 1 squared is positive 1. Squaring that is 16. And squaring this is 36, because a negative times a negative is a positive. So we do that in order to get all positive deviations, so squared. Now we're going to sum up that. So 36 plus 25 plus 1 plus 16 plus 36. That's 114. Now we're going to divide by n minus 1, where n is equal to 5 because there's 5 numbers. So we're going to have 114 divided by 5 minus 1. So 114 divided by 4, which is 28.5. So that value is 28.5. Finally, we're going to take the square root of that. So square root of 28.5, which is approximately 5.34. So that represents the standard deviation for that data set. A main use of dispersion is to compare the amounts of spread in 2 or more data sets. A common technique in inferential statistics is to draw comparisons between populations by analyzing samples that come from those populations. So if you calculate out 2 standard deviations, and one sample set is at 3, in another sample set standard deviation is at 5, then you know that the set with 5 standard deviation has more dispersion or more spread in the data. In this comparison, we can see 2 companies, A and B, sell small packs of sugar for coffee. The mean and standard deviation for samples from each company is given below. Which company consistently provides more sugar in their packets? Which company fills its packets more consistently? Okay, so which one has more sugar in their packets? That would be the one with the higher mean. So in this case, company A has a little bit more sugar on average compared to company B. But which company fills its packets more consistently? We could see that the standard of deviation, S, of group B is better. That means that they're more accurate in perfectly filling their little packets of sugar for coffee. So company B is more consistent in filling it, whereas company A typically gives more sugar in the packets. The next is Chebyshev's theorem. For any set of numbers, regardless of how they are distributed, the fraction of them that lie within K, standard of deviations of their mean, where K is greater than 1, it only works if K is greater than 1, is at least 1 minus 1 over K squared. So K is the number of standard of deviations of their mean. So an example, what is the minimum percent of items in a data set which lie within 3 standard deviations of the mean? Well, we could apply this formula, 1 minus 1 over K squared, where K is 3. So plugging 3 in for K, that'll be 1 minus 1/9, which is 9/9 minus 1/9 is 8/9, which is about 0.89 or 89%. So what that means is 89% of the data would, on a minimum, lie within 3 standard deviations of any set. The coefficient of variation is not strictly a measure of dispersion. It combines central tendency and dispersion. It expresses the standard deviation as a percent of the mean. For any data set, the coefficient of variation is given by V equals S, which is the standard deviation, divided by X bar, which is the mean. So this is standard deviation, and this is the mean of the sample. Or for a population, we use the sigma for standard deviation, and this mu for mean. And it's times 100, so as a percent. Compare the dispersions in the two samples, A and B. So based on those data sets, then we're calculating out for set A, we find the mean. Here's the mean. Here's the standard of deviation. And we want to calculate out the coefficient V. So the formula is V equals standard of deviation divided by the mean times 100. So standard deviation is 3.125 divided by 16.167, and we're going to multiply that by 100. So doing that calculation, we get 19.3. Then the second one is going to be a standard deviation of 25.294 over 153.167 times 100. And that calculation is 16.5. So what we find in here is, even though this mean is so much larger and the standard deviation is way larger than this standard deviation, still the coefficient of variation is smaller. So the 25 in comparison with the 153 is smaller compared with the 3 compared with the 16. So ultimately, sample B could have less variation with a smaller coefficient of variation.